First drill for today, the practice drill, is going to be the electromagnetism cheat sheet. So I'm just going to be basically building out a cheat sheet for the first couple of electromagnetism topics. So you can see I have the final topics that we're studying right here, and I got a big list of them, and I'm just going to paste them here and answer some equations. Now I've already got a cheat sheet right here that's already built out, but that doesn't really matter. That's not what I'm trying to practice here. I could verify whether all these equations are on the sheet, but I'm pretty sure that they are. The idea here is that I'm going to just be opening up a new file, and I'm just going to be copying down these things. So the vector and rotation rules, we're just going to go through and copy these things down. So this changed vector here, or I guess this is a vector, and this is for AXX. This is some basic vector things. And so what I'm doing is I'm trying to just drill some muscle memory for these equations that I've seen before, that I've got them on my cheat sheet, but this is what the robot thinks are important. This is a rotation matrix for the vectors, different dimensions. Here we have RTR is the identity matrix. Here we have A cross B I. This is the cross product using the Levi-Civita symbol here. And so this is for vectors and rotations. So the next topic would be something like index notation. So we can sort of copy out all this stuff and build a fresh cheat sheet that is only for practice. So we're not actually going to use it. I don't know why the symbol is here. Obviously, there would have to be more about this. This is going to be like +1, -1, or 0, depending on whether it's even swaps, odd swaps, or whatever. Let's go to the next thing. The derivative. This is like the gradient with index notation. Here we have the cross product again, but this is more of the curl. So I guess this is the div. This is the curl with the Levi-Civita tensor here. dj ak, and that's the curl. We also have the Laplacian, I think. It's like the second derivative type thing there. Okay, so that's for the index notation. Let's go to the next one. Here we have differential vector calculus. I'm mainly doing this for my own practice. This is basically exactly what I'd be doing if I was sitting there on my own. I would just get these equations and copy them down. Now, we could go through the textbook and do a similar thing, where you just kind of go through each chapter and just pull out all the equations. But this is the same thing we've seen before, isn't it? See, like we have some repeats right here. Before. Okay, what about this one? This is another repeat. That's fine. Nothing too fancy. Let's go to the next one. I'm just practicing. This is a practice video. So you can even practice along with me if you want. Just copy these down. Vector calculus. So here we have the integral of a dot dl. And we have this here, dot dA, a dot dA. And so I think this is Stokes theorem, and this one here is Green's theorem. The reason I know that is because this is basically one dimension to two dimension, and that's Stokes. You could think about stoking up the fire with barely stoking it up because we're in one dimension, two dimension. Here we're going from two dimension to three dimension. This is Green's theorem. The next thing is the electric field, and I'm sort of rushing through this, trying to write this out as fast as I can. Just copying down the equations that I kind of already know. And since there's nothing new here, that's why I'm sort of rushing through this and not writing anything fancy. If this was a completely new cheat sheet and I didn't have one already, I'd be making this look nice because I want to sort of get a foundational thing to start with, and then later I can fill it in and make it a little bit more fancy. But since I already have the cheat sheet, I'm just going through and just kind of drilling a little bit of practice. And the potential E equals V. These are pretty simple equations, but I want my hands to get used to writing them and be sort of familiar with like processing them. This is actually a volume right here. Let's go Laplace equation. Well, this is the Poisson equation for the conductors. So if you're doing this for the first time, it might be a good idea to make it a little bit nicer if you're going to be using this for class. The Laplace equation, sure. And we're almost done here with this drill. I just wanted to show you how I practice at home studying physics. If there's images, here we have to do something like this, where we take like Q plus over the R plus, and then we subtract the Q. I mean, technically this is plus or minus one, but this is kind of the best way I can put it. And if there's images like that, we have it in index notation like that. Separation of variables. So R, theta, and C, and we tend to put it like this. Let's try it like that. Like theta, I like a curly theta with a little theta. And then we have this special IO, the regular IO. Okay? And then we have this thing equals 0, leads to this type of stuff. Usually we consider the phi direction to be the azimuthal direction. Here is azimuth. We usually consider this to be pretty much symmetrical so that we don't consider our m's, we just consider the l's. Those are going to be like the Legendre polynomials and stuff. But we'll put it all in for the moment here. ELM r to the negative L plus 1. And so this is why LM, because we are considering the azimuth here. But if we weren't considering the azimuth, this would look a little bit more familiar. You'd see PL here of the cosine of theta. And then we wouldn't even have these M's here. Let's scratch those out. That looks a little bit more familiar. Let's go to the multiple expansion. So we have VR equals 1 over 4 pi epsilon and Q over R plus here is the dipole moment in the r hat direction squared, and then we start doing these crazy expansions here. Expansion AQ. I don't even know how to write this out. This isn't really the best way to write the multiple expansion. It's more better to do something like I'm thinking something like Q3, and then we have P3. This is cosine of theta, and then you'd have like this is r to the third here. You can continue to do that. Since this is Q naught right here, it tends to be equal to something like this right here, P dV. But we can often do just 4 pi r to the third over 3 with like a P naught here or something. Cool. And then we have P equals R E dt. Yeah. Okay. That's interesting. Okay, let's go to the polarization here. This is the final couple of topics for electric field, or so the electromagnetism, electrostatics, really. Electric dipole moment density. So yeah, it's kind of like P divided by the volume. And then we have the bound volume charge. When I do polarization, I like to have a dot right there in the P just to kind of separate it from other stuff. And then we have bound surface charge, another P dotted with the normal. Then we have electric displacement. That's going to be our D field, epsilon naught, E plus polarization. And the divergence of the D field gives us the free charge. And then we get into the linear dielectrics. It's the last topic, so we have polarization equals epsilon naught. This this thing here, an E. We're kind of rewriting this equation, sort of like that. It's just a regular epsilon here. And what is this epsilon but just epsilon naught times the material permittivity? And what is the material permittivity but 1 plus this thing? Awesome. So this is basically going to be the equations that we'd want. So if we sort of zoom out, we kind of see that, well, we've sort of prepared an outline for the cheat sheet. Maybe center this or whatever, give it some spacing. But if this was going to be like the first day of our course or something, this would be a great exercise because then we'd be able to sort of get all the topics down and have a little space for them. And you'd be able to sort of move it around like, oh, the potential should be next to the E field over here. So you could do that. Um, and then you could sort of reorganize it. The idea is like, yeah, this is a great thing to do on day one or on the first week of the course. You build out a little cheat sheet and you got some equations down. This is great to start with. Eventually, this is supposed to build up to something really, really big like this. Because I've already done it, like I didn't go through the exercise so neatly, but all of the equations that we wrote down are essentially on here. Like we can recognize basically everything from this. Anyway, hopefully that was a cool drill and you might have followed along. Got some questions here. So it says, any advice on preparing for lower division electromagnetic physics class? Yeah, I would definitely say it depends on whether you're already taking the class or like you're about to do an exam or something, or whether you're literally preparing for it. If you're preparing for it and you haven't taken it yet, then I'd say make a cheat sheet first, just like we just did right here. And then so that you kind of have an idea of what the equations are that you're going to go use during the class. Um, and like bring that cheat sheet around when you're taking the lectures and stuff, and you'll be able to update that cheat sheet over time. Another great thing to do is to like, if you're preparing for the exam, try reading solution guides, like straight up solution guides. And if you want to do like a transfer thing, another cool thing to do is just like practice tests of like multiple choice practice quizzes and tests like that, like the GRE test. It's good for like the graduate level, I guess, but I mean, it's good to do really hard stuff. So definitely those three things. I'll write them in chat here. So for preparation before the class, I would say make a cheat sheet with equations. Make a cheat sheet um, for uh, for preparation for transferring. Try doing like practice exams, like GRE or something like that. And then for preparations for exam, try reading solution guides like quickly. It's in like skimming them. Cool questions. Thank you so much for asking and showing up and watching the video. Anyway, y'all have a good